I welcome you all to this online program today. I really appreciated your comments and some other rest of things, and also appreciated those who subscribed as well, and also I appreciated those who solved their questions and sent the answers too. All is well. So don't forget, this time we'll be looking at the Gaslaw 105, and the topic that we really have there is called the Gaslaw. So the subtopic here is the Gaslaw's law of combining volume. So that is subtopic number 1, and the number 2 is Avogadro's law. That is what we are going to check here for today. So I believe everybody is on ground to get one knowledge or the other is part of it. So don't forget. So don't forget to mail us at fatherchemistry@gmail.com. You can also WhatsApp us at 08161685630. It's our official line, and you can also call us on the line too. Anytime, any seconds, we are ready to respond to your call. So don't forget to share the video with your friends. Share the video with your friends, and either Jambites or any WAEC students that they are ready to do WAEC, either WAEC, NECO, GCR, so you can also share it with them. It's meant for them too. So thank you very much. So we'll be looking at the first subtopic there, which is called the Gaslaw's law of combining volume. Now, when we are talking about Gaslaw's law of combining volume, here we are talking about moles. The moles that has to do with when what's called compound or element combined together. According to the what's called the Dalton atomic theory, one of his theories states that atoms combine together and they do so in a very simple ratio. So that when atoms combine together, they do so in a very simple ratio. So in this place now, what about, we've looked at the solid liquid. Now let us now look at the gas. The same thing applies to the case of the gas. That when gas combine together as well, they do so in a very simple ratio, which is equivalent to their volume. So without wasting our time, we go straight to the law, what the law states. Now, according to what I have here, Gaslaw's law of combining volume states that, I quote, at constant temperature and pressure, when gases react, they do so in volume, which are simple in ratio to one another and to the volume of the product if gaseous. I recap, at constant temperature and pressure, when gases react, they do so in volume, which are simple in ratio to one another and to the volume of the product if gaseous. Now, if you look at that statement, this is possible if only the temperature and pressure is kept constant. That is when it is possible that the volume of a particular gas is equivalent to their ratio, which is in a very simple ratio. Now let us take a look at the example that we have here. The example we have here, we have hydrogen gas which combine with oxygen gas to give rise to what? To H2O gas, which is called steam. The mole ratio that exists here is 1:1 to give rise to what? To 1 mole of water. That means 1 mole of what? Of hydrogen react together with 1 mole of oxygen to give rise to 1 mole of water. Now, the same thing happened in the example 2, where 2 moles of hydrogen gas combine together with 1 mole of oxygen gas to give rise to what is called 2 mole of hydrogen gas. Now, from what we have here, If this is 2:1 to give rise to 2 mole of this, then we can say that 2 volume of this now is equivalent to what? Equivalent to 2 volume of this react together with 1 volume of this to give rise to 2 volume of H2O. Now take note of the expressions that we have there. Now we'll be looking at one of the examples that we have here. We have UME 1984 question number 2. The question number 2 says that 20 cm cube of hydrogen gas has packed with 20 cm cube of oxygen gas in an endothermic at 373 Kelvin, 100 degrees Celsius, and 1 atmosphere. The resulting mixture is cooled to 298 Kelvin, 25 degrees Celsius, and passed over calcium chloride. The volume of the residual gas is A 40 cm cube, B 20 cm cube, C 30 cm cube, D 10 cm cube, E 5 cm cube. Now let us take a look at how we are going to solve the question. Now the first thing we need to check here, we need to check the equation of the reaction first. Now let us look at the solution to the question given here. I will quickly recap the question because of our time. Now the question is 20 cm cube of hydrogen gas as packed with 20 cm cube of oxygen gas. So in an endothermic at 373 Kelvin, 100 cm cube and 1 atmosphere, they now say that the resulting mixture is cooled to 298 Kelvin, 25 degrees Celsius, and passed over a calcium chloride. The volume of the residual gas is, now for the volume of the residual gas, here we go. First of all, we need to draw the equation for the reaction. So the equation for this reaction now, we can see that one to be the reaction that occurs between H2 gas plus O2 gas to give rise to what is called the H2O. So if that should be H2O, in balancing of the equation, we are going to have 2 here. This one will take nothing. This one will take 2 to balance the equation. Now that is to tell you that in this question now, the mole ratio is 2:1 to give rise to 2 mole of this. Now if that is 2 mole of that one, then let's check it out. Then we can see that the volume ratio now, volume ratio will also be 2:1 to give rise to 2 of this, which is 2 volume to give rise to 1 volume to give rise to 2 volume. Now, and from the question that we were given that 20 cm cube of hydrogen was packed with 20 cm cube of what? Of oxygen. So 20 cm cube of this one now was packed with another 20 cm cube of this to produce unknown cm cube of this one because we don't know it. Now we can say that before sparking, that is before sparking. Now reaction. Let us now look at the reaction that occur. This one remains 20 cm cube. Remember, 2 mole or 2 volume will be equivalent to 20 cm cube. So half of this one now will be 10 cm cube. Then to give rise to, for the 2 volume, we are going to have 20 cm cube here. So we can now say that after sparking now, what do we now have? When you remove this one from this, we have 0 cm cube. When you remove this from this, we are going to have 10 cm cube. And this remain 20 cm cube. So if that is 20 cm cube, now let us check it. From here now, to calculate the volume of the residual gas, Remember, that is what the question says we should calculate. Now, to calculate the volume of the residual gas, we are going to say that volume of residual gas is equal to volume of H2O minus volume of O2. Now, which means volume of H2 now is what? Is 20 cm cube minus volume of oxygen is what? Is 10 cm cube. Now deduct them. What are we going to have? We are going to have 10 cm cube. So the volume of the what? Of the residual gas is 10 cm cube. And if you check the option to that question, the answer is also there too. You can see the one that we have here, which is 10 centimeter cube. So that is the answer to the question. Let us continue with the question. So the example here, we have UTME 1989 question number 5. The question says the minimum volume of oxygen required for the complete combustion of a mixture of a 10 cm cube of CO and H2 and 15 cm cube of H2 is, let me recap it, the minimum volume of oxygen required for the complete combustion of a mixture of 10 cm cube of CO and 15 cm cube of H2 is. Now in the question now, what are they trying to say, or what are they insinuating? Solution. The solution to the question, they said the minimum volume of oxygen required for complete combustion of a mixture of CO and what? And H2. That means they combust CO in what? In H2, which now require what is called what? Oxygen, O2. Now, what will it produce? It will produce what is called CO2. Remember, all combustion reactions involve in production of carbon dioxide and water, H2O. Now, if you look at the equation that we have here, the equation on its own side, everything is balanced already. How do I mean? If you look at what we have in this place, CO, this is CO2 here, this H2 here, this H2 here, this O2 here. The number of oxygen here, this is 2 plus 1. That means we have 3. The number of hydrogen here is 2. We also have 2 here. The number of carbon here is also 1. We also have 1 here. So the equation is balanced. So in this equation now, then it can be quickly be deduced that this one 1 mole of this one react together with 1 mole of this together with 1 mole of oxygen to produce 1 mole of carbon dioxide and then 1 mole of water from the equation. Now, on that aspect, and don't forget from the question now, it seemed to be altogether, we can say that the mole ratio is 1:1 to give rise to just ordinary 1, since they do so in a very simple ratio. Now, then let us check it out. In this place, you were given the, what's it called? The volume. Don't forget some volume were given to you. Let's check the volume. You were given from the question. If you go back to that question, you can easily get what we have there. You were given from that question that for the complete conversion of a mixture of a 10 cm cube of what? Of CO. That means we have 10 cm cube of this one, cm cube of this one, and what? 15 cm cube of H2. For the H2, we have what? 15 cm cube. Now, to produce unknown here, because the volume of this one was not mentioned. So if the volume of this one was not mentioned, and the ratio that exists between them is 1. Why? Because even though from the reaction we can see that carbon dioxide is produced to be 1. So in this place now, without wasting much of our time at all, now, we can see that hydrogen is in essence. So in that case, the answer to the question is 10 cm cube. Take note, 10 cm cube, that is the answer to the question. So what does that require? It means the minimum volume of oxygen required now for the complete combustion is what? Is 10 cm cube. The minimum volume of oxygen required is 10 cm cube. So take note of that. And I think from the question, we'll have our answer here. If you look at the question number 5, the answer to the question is option C.